Okay, Assalamualaikum and good morning. Okay, today we'll start on HVAC electrical control on the first topic, which is electrical safety or basic electricity. Electrical safety. Electricity is an extreme powerful force and should be never treated in careless manner. Common working voltage of air conditioning or refrigeration from 224 volt up to 480 volts. One mistake could lead to death or injury. Never work on and energize circuits if it's possible to disconnect the power. So if you need to work, you make sure that you disconnect the power that you have. Okay, to ensure that you already off your power, this is the steps actually. The first one, you have to ensure that your meter, the meter that you use is operate. And so test the meter on a non-live circuit to ensure the meter is operate. So when you test, when you have a power meter, a volt meter, ammeters, so you test it and you are very sure that there is the live circuit. So means the lamp is already on, then you test your meter, and then you know, okay, the meter is functional. Then what you want to do is you test the circuit to test on a circuit that you want to test, circuit that need to be de-energized, and then you test back the meter to ensure that the meter is still operating. Okay, next what you should do is you have to know the general safety rule lah. The first one is think safety before you start. What you need to do, you have to think first. Do not touch or with your hand or with anything without thinking of safety. Do not depend on the circuit breaker. You don't, because you don't ensure that the circuit breaker is still functioning, or fuse or someone else to open the circuit. For example, you want to test your lamp, test your HVAC circuit, and you ask your brothers to open it. So do not ask them. You have to do it yourself. Test yourself before you touch it. So you need to test it first using meters. Use insulated gloves or meter probes designed for high voltage equipment. If you need to use high voltage equipment, ensure that you use gloves. Next one is electrical safety on one set of load contact to break. This is example one set of load contact to break 240 volts. This is they only have one contact, but the other contact is still on. The other one, you have two load contact to break both sides of 240 volts. And this time mean that the circuit is 100% break. This one you don't ensure because it have the one this one side is still on and the other side is off. And then don't play horsepower, don't play around. Don't work alone. You need somebody else to help you if you have anything. And then work with one hand when possible. Why? This one you need to Google lah. Kenapa? Why you need to work with one hand rather than use two hands when you handle with the circuit. And I'm not sure whether they have it here or not. Why you need to work with one hand? Anybody could answer? Think why? With two hands, you will make the circuit complete one round, so the current could move from either your left hand or your right hand towards your body, and that's why you need to work with one hand. Learn first aid. This is the thing that you need to learn before you handle electrical equipment. Effect of electric current on a body. So what are the effect of electric current on the body? How you want to reduce it, if possible. Electrical safety. Okay, this is basically the electrical currents effect when it goes towards your body. If from that and 0.1 up to 0.0, sorry, this is 0.02 up to 0.1 ampere. So could be that. So very painful is 0.01 to 0.02 ampere. Moderate sensation is 0.09 to 0.01 ampere. Yeah. Okay. What are the big energy usage component in HVAC? So when you think of HVAC, what are the components that you know? What the main components which are the most used electricity? Yeah. Here, for example, you have a cooling tower there, you have pump, fan, boiler, you have chiller, supply air, return air, and which one uses the most current? So basically, these are the big energy usage in HVAC, which is the first one is fans for air circulation, cooling, and we have heating also, and pumps and cooling towers. These are the big energy usage in HVAC. Yeah. Okay, definitions. Voltage is defined as electrical potential difference that cause electron to flow. Current is defined as flow of electrons and is measured in ampere. Resistance is defined as a position of flow of electron and measured in ohms. So here only definition. Perhaps you could remember it. Who knows when it comes in test or final. So and then we have here the formula for V equal to IR, who is a constant resistance. What happened? What happened to the current when the voltage is low or high? Is this formula. So what happened? A lower voltage give a small current, and high voltage give a large current. So how you want to know whether it is like that or not? Okay, here as you can see, you have a formula of V is equal to I R. So what happened? V is proportional to V is proportional to I R. So when V is high, I is also high, R is also high. When V is low, I will become low, R will become low because it's proportional. So with constant resistance, this is another example, another question. With constant resistance, what happened to the current when the voltage is low? Low voltage give small current, high voltage give large current. When this is constant, means this is C, for example, it's non. So it is still proportional, still proportional. So this low, this one also low. What happened to the voltage when the current when the resistance is low or high? What happened to the current? Lower resistance. Okay, what happened to the current? So you need to bring current over here. So it's equal to V is equal to IR. So I is inversely proportional. I is equal to I 1 over R. Inversely. So what happened? Inversely, this one, when the I is high, R, sorry, this is not I is equal to 1 over R. Jumlah. So inversely proportional, and then what happened? This is inversely so when I is high, R is low. When I is low, R is high. Okay, inversely proportional. Next, this is example of conductor. Conductor wire has a resistance of 15 ohm. So and current flowing in the wire is 5 ampere. So voltage drop along the wire will be, so here you need to calculate lah using the V equal to I R formula. So V is equal to R into calculate R, and R equal to V over I, and you got this. And resistance of heating implement from electric water heater operating at 240 volts as current 14.6 ampere resistance. R is equal to V over I, and you got 16.4 ohms. Okay. So next one is every circuit comprises in 3 major components. This the first one is conductor, conductive parts such as wire and printed edges on circuit boards, sources, for example electrical power, battery, household outlets, and the third one is loads. Okay. Loads that need electrical power to operate, such as a lamp. So we have 3 things. The first, conductive part, and then we have sources, and we have loads. And the 2 optionals could be included in the electric current. The first one is control device, the second one is protective device. For example, we have a path, this is a wire, and we have a source, this is a battery, and we have loads, so this is lamp, so this is source, wire, and lamp. Wire is positive path. Okay. So another one that we could protect, this one is we could put a fuse, for example. Fuse, put a fuse for protective device, or we could put a switch, switch like this, switch and fuse. Okay. Okay, here list up control device and protective device. What are the protective control device and protective device? This you need to submit in ULEN lah. List up and submit in ULEN. One that you can see. Okay, next one. Type of circuit. So here we have a series circuit, parallel circuit, open circuit, short circuit, power circuit, control circuit. So we have 6 of type of circuit. The first circuit is series circuits. Series circuit is defined as circuit which the element is in series. So everything is in order, and we have this is sources. So goes to resistor number 1, resistor number 3, and so on. So when we have this series circuits, this is the formula. I total is equal to I1 plus I total is equal to I1 is equal to I2 equal to I3. So I is equal, in this circuit I is equal. So V total voltage. So voltage is equal to V1 plus V2 plus V3. So voltage equal to V1. This is E lah. E YE. This is energy. Actually, this is from US sources. So US sources denoted as E. So E1 plus E2 plus E3, or V1 plus E2 plus V3. So then we have R total. R total is equal to R1 plus R2 plus R3. Okay. Let's look on parallel circuits. These parallel circuits, for example, they have a parallel three type, parallel three resistant in parallel. So R1, R2, and R3. So the formula is V total is equal to V1 equal to V2 equal to V3. So V1, this is actually they put here. This is how you want to measure V voltage. When you have a multimeter or ammeter, you need to measure. You put measure how much V is running to this R. So you need to measure. Put one here over here. Put another one over here, and you got voltage or energy of it. So if voltage 1 is equal to voltage 2 equal to voltage number 3 is equal. So if this is 10, this also 10, this also 10, means you also 10. Okay. So I total is equal to I1 plus I2 plus I3. Okay? I is current. Current. For example, you try assume like a water, for example, a river. A river go here because they have currents. So it's been split into three parallel. So if been split means this is I1, I2, I3 plus together you get I total. And this is 1 over R total. How to calculate R total is equal to 1 over R1 equal to 1 plus 1 over R2 plus 1 over R3 plus over Rn, whatever R that you have after this. If you have a number Rn, R3, R4, R5 and so on. So you got 1 over R total. Hopefully everybody still remember. So 1 over R total, 1 over R equal to 1 over R1. For example, on this everything you total up, you got 0.5. So R total is equal to 1 over 0.5. So you got R total. Okay. Okay, next one is combination. Okay. This is combination of parallel circuits and also series circuit. Okay. I know you already learned before this. This is fresh for you. Okay. So we have here, this is parallel, this is R. So how to calculate it? Please look back how to calculate it. So this is example of circuit. Okay. For example, here this is the combination circuit. For example, you have E1, E2, E3, or resistor number 1, resistor number 2, resistor number 3. So how to solve it? The first thing you need to remember that you need to combine these two parallel, make into one. You got EC over here. You got EC. So when you got EC, then you could this is become series, and then you could calculate. This is how you have to solve it. Okay. For example, this is example. They give the value already. Okay. So let's solve it. And you got the answer, right? Okay, and then this is exercise. Okay, this exercise you need to submit in Ulan. Okay. This is E1, E total, I1, I total, R1. You got this is the value that you have. So by having a look at this is E1, I1, R1, E3, I3, R3, E2. It's everything is 2 lah. This is 4. Everything is 4. So this is the table you need to fill it in. Yeah. Next is series seal skirt lah, same as before lah, tapi a bit different lah. Because this time they put